Electrical voltage tester. Inventor of voltage tester is Hugh F. Mahaffey. He invented the voltage tester in 1935, he worked for Wigginton Company and he applied for patent in 1937, he got the patent in April 6, 1937. This is a part of his research work. We use voltage tester in our day-to-day life whenever required. So, what is a voltage tester? Voltage tester is a very simple piece of electronic test equipment to determine the presence or absence of an electric voltage. These are the components of a typical phase or line tester. 1. Metallic rod and mouth. It is a cylindrical metal rod. The flat end is used as a screwdriver or to touch electrical conductors or wires to find phase or live wires, and the other end is connected to the resistance. The flat end of the cylindrical metal rod is covered with a transparent insulated plastic for insulation purposes except for the mouth. 2. Body and insulation. The components resistance, neon bulb, metallic spring, and a certain part of the flat end of the cylindrical metal rod are covered with a transparent insulated body made up of plastic. 3. Resistor. It is an element which opposes the flow of current through it. The resistor is connected between a cylindrical metal rod and neon bulb to prevent high current and reduce it to a safe value for a neon bulb. Without a resistor, high current may damage the neon bulb. Moreover, it would not be safe to use this tool without a resistor. 4. Neon bulb. The neon bulb is connected between resistance and metallic spring. It is used as a phase indicator bulb. When a small current flows through it, the neon bulb in a tester glows, and so it is called a neon screwdriver. 5. Metallic spring. Metallic springs are used to make connections between neon bulb and metallic cap screw. 6. Metallic cap screw and clip. The metallic cap screw is used to tight all the components inside the phase tester slot. In addition, the metallic cap screw is connected with the spring and the spring is connected with a neon bulb. Actually, clip is used for holding the phase tester in pocket. Working of a phase or line tester. When we touch the flat end of the metallic rod of the voltage tester touching the naked live/hot wire, then the circuit is completed and current starts to flow in the metallic rod. Metallic rod is connected to the resistor, which reduces high current to a safe value. The reduced current passes through the neon bulb, which is connected to metallic spring and in turn is connected with a metallic cap screw which is in contact with our fingers. A very small current passes through our body to earth and completes the circuit. When the circuit is completed, current starts to flow and the filament of the neon bulb starts glowing. This indicates that the touched wire with phase or line tester mouth is phase. Good to know, phase, line, hot, live and positive are the same terms. If we perform the same action as mentioned above, and the neon bulb does not glow, it means that it is a neutral wire or conductor. The electrical tester is a simple series circuit. The lead of the electric tester is touched with the circuit to be tested. Circuit gets completed through user body impedance at 50 Hz, internal resistor and small bulb as shown in the figure to give indication of live circuit. The 240V supply drives some current through the series resistor, whose value is chosen such that no harm is caused, generally in megaohms, and through a spring and external cover lid. Here current flows from supply to earth, through a person's body whosoever touches that. If I put the tester inside the phase of an electrical socket, the light inside the tester glows when I press my finger against the metal cap on top of the tester. Bulb glows. The voltage tester works. It is a phase or line. This happens also if I stand on a surface of insulating or isolating material such as wood, plastic, etc., the light will glow, glowing dim. Yes, I have read this, as it happens due to capacitance effect formed by the human body and phase wire. Z equals R plus 1 by JWC. Where Z is impedance. R is resistance. 1 by JWC equals XC is the reactance of a capacitor. Impedance. Impedance, denoted Z, is an expression of the opposition that an electronic component, circuit, or system offers to alternating and/or direct electric current. Impedance is a vector, two-dimensional, quantity consisting of two independent scalar, one-dimensional, phenomena, resistance and reactance. Resistance. Resistance is an electrical quantity that measures how the device or material reduces the electric current flow through it. The resistance is measured in units of ohms, ohmega. If we make an analogy to water flow in pipes, the resistance is bigger when the pipe is thinner, so the water flow is decreased. Reactance of a capacitor. Capacitive reactance, XC, is a measure of a capacitor's opposition to AC, alternating current. When the capacitor is high, the impedance should close to resistance, the effective resistance of the formed circuit. Why is resistance small enough to cause a current in the range of mA even if I stand on an insulating or isolating surface? Please ensure whether the tester is in a good condition, else you will get an electric shock. Post your queries in the comment box.